Hi everyone, my name is Satara Moment and I'm presenting my topic on hospital waiting room simulation program, which I hope you guys enjoy my presentation. When you rush yourself or a loved ones to the emergency room at a hospital needing immediate medical attention only to be greeted by a waiting room full of dozens of others who also need urgent care, it makes you think what solution can be implemented to reduce the wait time. Number of emergency room visits increased to 141.4 million patient visits since 2014 per data retrieved from the Centers for Disease Control and Prevention on September of 2017. People are visiting emergency department for different reasons. The top reasons for emergency visits include chest pain, stomach pain, shortness of breath, injury, and pain. Chronic disease was a factor in many emergency visits, with hypertension being the most frequent condition, followed by diabetes, asthma, depression, substance abuse, coronary artery disease, and COPDs. Waiting times at each emergency department varies depending on the available resources. Based on the statistics from CDC, 32% of the patients are being seen by a doctor for about 30 to 45 minutes. 68% are seen for about 60 to 75 per minute, and about 10% are seen for more than 6 hours if they have to be admitted to the hospital. One of the solutions that I think will be helpful to reduce the waiting time based on the available resources is using a program module based on Python, which is a program called SymPy, to reduce the wait time for patients in more urgent treatment needs. So let me switch my screen to the Python so I can better explain my program and how it will work. To run my program, I have to use a Python environment, and from here I have to import SymPy, which is going to be helping us to do the simulation problem. And we're going to use NumPy so we can be doing some mathematical calculations. So we are using this global variable. Based on these variables, we're going to be calculating the wait time at each emergency room. The way it works is that when you go to emergency room, you're going to be arriving at a time. Then you're going to be spending some time at registration, some time at the nursing station where you can get some vital sign be done or some lab work might be done. Then you're going to be seen by a doctor. From there, you're going to be going whether admitted to the hospital or being discharged. What is important for us is the wait time. Now, if we have the bigger hospitals, different nursing stations, and different patients, we can change these numbers based on each situation. So we have to randomly run this program, and this code here will generate some results every time you have to run this program based on the random numbers that is going to be different each hour. So we're going to use this function to create some patient and their arrival time, and of course we have to use a while loop for generating these patients. And since it's not a definite, we cannot predict the time and the number of the patient arrival, so we have to have a random time generator, and also the time be random for the registration, nursing station, doctor station, and the departure time or the discharge time, and as our patient comes through here. So we have a patient flow process each time that it will go from the beginning of registration to the discharge time, and it can go till when we have available resources. By resources, we mean that till we have enough doctors, till we have enough nurses for each station. So let's say the patient's number 1 enters the registration, and now after getting registered, that patient will go to the nursing station. So the second patient can enter the registration, and the first patient can go from nursing station to the see the doctor, and then the second patient will go to the nursing station, and the third patient can go to the registration, and this process follows as long as we have the available resources. So again, if you have a bigger emergency room with more nurses, more nursing, and more doctor, and more registration stations, you can be doing this program in a way that it can have more stations to be run and more functions to be done. But right now we are doing as we have these available based on the number that I put in here. And to run this program, I do need the SymPy simulation program to actually initialize these environment and initialize a random number generator. And the time that I give to this program is for 1 hour. So let's run this and see what happens. So let me just go this side and let's run this one. Okay. So if you look here, based on the number I have entered, I have total of 14 patients that enter emergency room. And if you look, it's going to give the average wait time for them is about 1 hour and 20 minutes, let's say. So, which is kind of not bad according to average of the number of patients being waiting at emergency room was about that time. So if we have different patients coming in, we have this program at the emergency room and tells the nursing station that, hey, this is how the number of hours your patient going to be waiting. So then they can actually prioritize the patient to be seen by the severity of their injury, not by the first come, first seen basis. So this program, computer-generated programs, actually help healthcare providers to provide a more linear process and actually help them to use their resources in more wisely manners. In conclusion, computer-generated programs are way faster, which needs less personnel to work. It will help the ER personnel to use more organized way of seeing patients rather than using the traditional paper and chart recording process, which it takes time to register patient and assign them by manual process. Patient can be seen based on the severity of their visit, not based on first come, first served. And overall, it will lead to a linear process, which is the goal of most of the hospitals. If you have any questions, please make sure to write it on the discussion board. And if you need more information about the topic, you can refer to these resources. Thank you for listening.